Hello, and welcome to the 6th episode of KASA RPL. On the pad for today's first launch is Chembro, an infrared telescope that will be mapping the sky in wavelengths above that visible. It will detect things in space that give off heat rather than light. Its destination will be low Earth orbit. Here we go. You are currently seeing the booster cams provided to us by Holcam VDS. This vehicle is a triple stage with solid rocket boosters to increase the thrust-to-weight ratio at launch. The first stage is 4 LR-89s, each producing 758 kilonewtons of thrust. The first stage, including the SRBs, has just under 4 kilometers delta V at sea level. At launch, the thrust-to-weight ratio is 1.66. This is essentially the amount of gravity felt, one being that equal to Earth's gravity at sea level. Just before the first stage burnout, the thrust will amount to that of 4.5 Gs. The second stage is an N1 with 600 kilonewtons of thrust, just over 2 kilometers of delta V. Its job is to help boost us into an almost circularized orbit. Its starting thrust-to-weight ratio is 1/2 G, and ending is 1.6. A low thrust-to-weight ratio in the second stage is necessary for an increased amount of delta V. A higher thrust-to-weight ratio is always preferred, but rarely efficient. The final stage is a payload assist to boost the satellite into a functional orbit. It has a little over 800 meters per second in delta V and a thrust-to-weight ratio of 1/3 G at start, ending with just over 2/3. The first NASA infrared telescope was IRAS. It was launched in January 1983 with a 10-month mission of mapping the entire sky. It did so 4 times in the 12, 25, 60, and 100 micrometer wavelengths. It discovered about 350,000 sources, a lot of which have yet been identified even today. Just like our infrared telescope, its life was determined by the amount of liquid helium stores it had. Because infrared telescopes are sensing heat, they have to be cooled to cryogenic temperatures. IRAS operating temperature was 2 degrees Kelvin. That's about minus 271 degrees Celsius, which is about minus 455 degrees Fahrenheit. Extremely cold. Telescopes is the theme of this episode, this one being an optical telescope, with an added science experiment that we will hopefully return. I think the launches are getting a bit repetitive, and I'm pretty sure you know the routine, so I will just skip through the liftoff, ascent, fairing separation, stage separation, and here is deployment. We're just going to do a quick test of the telescope by getting our first close-up shots of the moon. Everything checks out, so we will go ahead and deploy it for operation. I'm sure our scientists would like to get it calibrated and taking pictures of the sky as soon as possible. So the probe that deployed the telescope did indeed expose its biological sample to space, but unfortunately did not have enough delta V to set up the correct return trajectory. And it ended up burning up in the mesosphere. So we are launching a dedicated mission to gather that precious science that we missed out on when our former probe was lost. We are still tailoring launch vehicles to the mission. This one has 4 large solids that are recoverable. So again, we will skip through the launch, SRB separation, first stage burnout and separation, fairing separation, and third stage separation. We have to reorient one of the Spacecom communication satellites to point at our probe so we can ensure communication to finish our circularization burn. Once that is done, we can start gathering science from our many instruments. First up, the first biosample analysis reports everything intact. Next, the mini goo radiometer records the goo's activity in a zero-G environment for later analysis. The Gravimax negative gravioli detector's sensors find subtle changes in the gravitational field. This is actually a thing that exists. If the density of the stuff between you and the point mass you are orbiting fluctuates, it can really mess up your orbit. Earth's gravitational field fluctuations are pretty mild, largely because of the molten mantle and core of the planet. The Moon, on the other hand, has a much less active core. This is likely to have caused its varying gravitational field, which makes stable circular orbits nearly impossible over a long period of time. Last up on our space science gathering mission is the second biosample analysis, which reports complete and ready for return to the Swedish government. Now we will begin preparation for re-entry. First, a transfer of electricity to the probe. Next, we will flip the craft around and use the monopropellant to thrust until we have a periapsis of about 64 kilometers. Just before we hit the atmosphere, we will ditch the fourth stage, which is extra weight and could cause instability during descent. We flip the probe around to point the heat shield in the direction we are traveling. So as we come in, I'm trying to get some science from the upper atmosphere, and that boundary is much lower than when the shock heating starts. We were hoping to come in over the west coast of Africa because we have a surface sample experiment that we'd like to do before recovering. The explosions that you see are expected. They are the RCS ports on the heat shield and those sticking out from the sides of the RCS tank just behind the heat shield. The heat shield seems to be holding up well. It's only reached about 800 degrees Celsius. It has a maximum temperature of just over 1600 degrees. We will just grab a little bit more science before splashdown. The goo jiggles and wobbles as the craft flies. Although we aren't flying, we are falling, and it's in a low-G environment. Atmospheric pressure scan has completed its survey. For some reason the parachutes opened down. Maybe I put them on upside down? I think this is a problem with the Nova Punch animation DLL, but I haven't figured out what to do about it. Shooting lasers in the sky gives us 16 science points. I'm not sure if the water is supposed to be really wavy or if that's a bug. It seems like it's gotten a little bit better since the last real solar system update. Thanks for watching. If you like this video, please click the like button. Be sure to tune in next week when Pioneer makes it to the moon. This has been Grim doing rocket science so you don't have to. Arrivederci.